generalized parameters. Now, what is our goal is to increase the or improve the voltage when we apply the force. So voltage actually generalized as a parameter, TRIZ parameter force, because we generally call it as electromotive force. So that's the reason why. So we take all the time the voltage as a improving parameter or power as a improving parameter, and all other things we will work out as a deproving parameters or worsening parameters. So this is what we are going to do. So that is the reason why in this list, whatever you see as potential difference is taken as improving parameter. So you may note down. So our one and only improving parameter is potential difference, because that is what ultimately we want from that device. So our improving parameter is potential difference. So potential difference with respect to other worsening parameters. That means with respect to other parameters, how we are going to improve this one. So that is what we are going to work out. So we will keep the column, that is constant force, and other things will vary. So that way we will work out for each contradiction. So force versus stability of the object composition. So can somebody tell what are the numbers here? Force is of
10,
force is 10, stability of the object composition is
13.
30. Now you please see the contradiction matrix which I told you yesterday. Please go for the contradiction matrix. On the column, that is improving parameter should be the force and worsening parameter should be the, you just please look at where is the force. Improving parameter should be the force and worsening parameter should be the stability of the object composition. So force and somewhere stability of the object composition. So I think after strength there is a stability. So 35, 10, 24, 21. Please note down those numbers: 35, 10, 24, 21. What are these numbers? These numbers are the keywords to solve the contradiction. These numbers are called inventive principles, which are actually show the way to solve the contradiction between the force and stability of the object composition. So that is what you are going to do now. So for hope you noted down, that is 35, 10, 24, 21. Now actually I will show you the inventive principle list. So the list of inventive principles, if you see, so these are the list of inventive principles. So you can see here the numbers, that is 1 to 40. So how many number of inventive principles are there we have? So total 40. So please note down number of inventive principles in brackets keywords for solution. Number of inventive principles in brackets keywords for solution. So that is what you need to consider these as. So keywords for solution are total 40, which we call them as inventive principles. So what are our numbers? What is the first number? 35. So transformation of properties. So those are the definitions. In order you to understand what is that. Okay. So transformation of properties is first keyword. Okay. That may be change of physical state of the system, change of concentration or density of the system, change of degree of flexibility of the system, change the temperature or volume of the system. Anything that parameter should be changed or property should be changed. Okay. So that is the meaning. That is the first keyword. What is the second keyword? What is the second number after 35?
10.
10. So 10 is prior action. That is the second keyword. So prior action is perform required changes to the object completely or partially in advance. That is the meaning. The same way, place objects in advance so that they can go into action immediately from most convenient location. Okay, so you need to understand this keyword as per these definitions. So general understanding should be acquired. So that is the second keyword. Please note down prior action. What is the third keyword? Number
24.
27. Please quote.
24, sir.
Sorry, 24. Mediator. 24 is the mediator. See, these names may change in different list because they just indicate, but definitions are same. Don't worry about it. Okay. So total 40 inventive principles are there, which we call them as keywords for solution to solve that contradiction. Okay. So mediator. Mediator means what? In that definition is use an intermediate object to transfer or carry out an action. That may be anything. Okay. That may be charge separation. That may be voltage generation. That may be flexibility. Anything. So there should be some intermediate object which actually reinforce the uh, effect. Okay. So temporarily connect the original object to one that is easily removed. It's a kind of a temporary part you are going to create in the device. Okay. So the keyword is mediator 24. So what is the last keyword? Last one. Number
21.
21. So rushing through. So rushing through, or some places they will give you as a skipping or something. Okay. So rushing through is perform harmful and hazardous operations at the very high speed. That is the definition. Rushing through. So perform harmful or hazardous operations at very high speed, whichever you feel is not good for the person who is performing those operations you do with a very high speed. That's it. Okay. So these are the four keywords you are actually using in order to solve that contradiction. So which contradiction? The contradiction between force and stability of the object composition or continuity of the surface. Now you tell me how you can connect. So that is where your ability of the design will come into picture, because storytelling is part of the design, right? Now you create with you create numbers. So just 35, 10, 24, 21. So these are the parameter changes or changes in property. Second, 10 is having something, 24 is something, 21 is something. How you are going to connect all these four in the context of this one. Okay. How you are going to connect all these four keywords meaningfully in the context of this one. Okay. Especially what is the parameter here? Stability of the object composition. That is continuity of the surface. So here changes in property means property of whom? So first keyword is saying that changes in property. So property of whom? I'll go back. Property of whom? Property of this material surface. Okay. Property of this material surface. What is the second keyword? 10. What is the name of the second keyword? Principle. No, 10. What is the name indicated there? Prior action. So prior action is Performance required to change an object completely or partially in advance. That means what you actually change in advance. What do you want to change in advance? As per your contradiction, what you want to change in advance is stability of the object's composition. That means continuity of the surface. Means what? Any idea? Any guess? That means before you start the experiment, you want to do some changes over the surface of this material. So what does it mean? What does it mean? Any guess? Now, this is very difficult to teach in online, but still I'm trying because some people may learn, will be useful tomorrow. So what do you mean by if I want to change in prayer, what I'm going to change here? Surface continuity. That means I am going to change the patterns. I am going to keep the surface either random or patterned, but it is not going to be smooth. Okay, so please try to understand. You have the stability of the object's composition, which is related to continuity of the surface, where you need to make property changes. You need to do prior action. You need to do, what is the 24 number? Mediator. What is the 21? What is 24? Yeah, 24 is mediator, 21 is rushing through. So any harmful action is there? So harmful action is nothing is there. That's why seems they excluded. Okay. So you consider please 35, 10 and 24, then connect them in a very meaningful manner in the context of this parameter or in the context of this conflict. Tell me, in order to improve the potential difference, which is termed as force, what you are going to make in the continuity of the surface. What you need to do is, please add one mediator over prior to the patterning of the surface. That means you are going to play with the continuity of the surface. That means you are going to pattern the surface in such a way that you will add one intermediate layer there. So that is the way I'm going to connect these things, and that statement I'm going to write here. So that statement I will tell you, I'll show you after doing one more contradiction. Hope you understood how we are doing or how we are actually using the contradiction matrix. Okay, so force and shape. Okay, next contradiction is force and shape. Tell me what to do now. What is the number to the force? It is, no, forget about the number. You tell me the force, shape. So in contradiction matrix, what are the keywords or inventive principle related to force versus shape? Y-axis is always same. Improving feature is same. That is force. Improving feature is force.
10, 35, 40, and 34.
10,
35,
35,
40,
40,
34.
40, 34 or 3 ma?
So 34.
34 huh?
Yes, sir, 34.
Okay, 10, 35, 40, 34. Yeah, please. Now in the inventive principle list, what is 10? So how many inventive principles we have? Total 40. So in that, what is 10?
Prior action.
Prior action. That means there is a definition. Next, what is 35? Transformation of properties. Okay. So which property we will decide, okay, based on the contradiction. So transformation of property. Another is 34, that is rejecting or regenerating parts. Means what? Definition is here. After completing its function or becoming useless, an element of an object is rejected or discarded or modified during its work process. Okay. Use up parts of object should be restored during its work. Okay. Any one you can take up as per your understanding and applicability of the applicability in this case. Okay. Rejecting and regenerating parts. Rejecting and regenerating parts is the 34. Next is 40. 40, what is this? Composite material. That means replace homogeneous material with composite ones. Composite means complex. Okay. So those are the four keywords. One is 10, prior action. Second, 35, transformation of properties or change in properties. Third is composite materials. And fourth is rejecting or regenerating parts. Okay. So, and another thing I think maybe which table you are seeing, the table which I am following is showing 3. Okay. It may not be 34. Please correct it. Shape I am telling. Okay. So it is not 34, it is 3. Okay.
So it's showing 37 to thermal expansion also.
Just a minute. Here 35, 10, 40 and 3 is there. Please correct it, 3. Maybe I will forward you standard contradiction matrix as well as the inventive principle definitions. No problem. Okay. Because there are a lot of modifications. Don't worry about them. So you put the last principle as 3 instead of 34. Okay. Because I downloaded from the TRIZ, this systematicinnovation.com. Okay, I'll forward you. Don't worry. Yes. So here, what are the numbers now? 10, 35, 40, and 3. These three numbers are same, but you are saying 34, but it's a 3. Maybe in the mistake in that things. Let us follow the standard one. So 10 is, and what is the 3? 3 is the local quality. Local quality means transition from homogeneous to heterogeneous structure of an object or outside environment. Okay. So homogeneous to heterogeneous, and different parts of the should be carried out different functions. Each part of an object should be placed under conditions that are most favorable for its operation. Okay. So that is the fourth one. Or suppose if you think that no sir, we want to consider only 34, that is also fine, don't worry. 34 you. So after completing its function, becoming useless, an element of an object should is rejected. That means use and throw materials you need to use in your device. Okay. Now, so what you want to take, 34 or 3? Let me know. Don't worry, because I told you have to follow 3. Maybe we'll work out with 34 also. So now, what is your actually shape surface pattern? Shape you want to change. How you want to change the shape? 10 is, what is 10? What is 10? You see in inventive principles. Prior action. 35 change in parameters or transforming the parameters. 40 composite materials, and 34 there should be, what is the 34 definition? 34 used up parts of an object should be restored during its work. That means almost using. So it's a kind of a use and throw parts. Okay, I don't know how it is going to apply to our situation. So then now you tell what to do. Composite material, definitely you are going to use. And change in properties or parameters means you are going to use the patterned composite materials which may be replaceable. Okay, which may be replaceable. And other thing is, these things you are going to do in prior to the system fabrication. That means where you need to do, I already shown you. Yours is shape, that is surface pattern. So this surface pattern where you are going to do, you are going to do in this material, but here not normal surface pattern. The surface pattern should be of composite material. Composite material means it is not actually of a single material. It should be like a compound scheme or compound materials. Okay. So this composite material with pattern you are going to fabricate, which can be replaceable in prior to the device fabrication. Okay. So that means what you are doing, you are just connecting these four keywords in the perspective of shape. You are connecting these four keywords in the perspective of the shape. So that is where you are getting one statement. Okay, like this, we need to perform all the contradictions. That means you see the contradiction, check the contradiction matrix, then find the inventive principles or the keywords for your solution. Solution to what? Solution to this contradiction. Okay, so if you do that, actually you can get this statement. Statement means what? You have to connect all these keywords in the perspective of this parameter. Okay, once you connect those things, you will get some meaningful statement that will give you an idea what to do in order to modulate the shape to improve the voltage. Okay, so this is what we are going to do for every conflict where improving parameter is force in all cases and worsening parameters are always the other parameters. Okay, now so this is what we did here, and here I took 3 instead of 34 because my table is showing that one. So let us follow the standard one, I don't mind. Okay, because with respect to subject also sometimes they change the table, so no problem. So we do like this. So here everything is written, all the inventive principle for every this for every contradiction. So now next what we are going to do, we are going to connect these four things in the meaningful manner, which is actually stating about this parameter. Changing the density of the layer distributed in plane, sorry, this is not plan, this is plane prior to the intermediately connecting layer coating quickly. This rushing is quickly. That is true. May not be suitable for this one. But 3, if you connect, what you are going to do, changing the density of layers. This is the meaning I brought. Changing the density of layers. Density is the parameter. That parameter of layer you are going to change. in prior. That means that's a preliminary action. In prior to what? In prior to the intermediately connecting layer coating. Intermediately connecting layer coating. Forget about this quickly. Okay, that is unnecessary. So how fast we do is our duty. Okay, so layer coating. So that way I connected three keywords here in a meaningful manner, which is related to this uh, uh, this parameter or this contradiction. Okay, so now same way, force versus shape. We have four, then I connected them in a meaningful manner, where pattern with pre-induced form deforming agents. So pre-induced, what we are doing, preliminary action, form deforming agents. So here actually I'm deforming the form. Okay, I'm not changing the density, I'm deforming the form with some additions before the device fabrication and 2D material distribution. Agents that make 2D material distribution, because preliminary action is adding some agents which make it composite material as well as change parameter. So that is what I told here. Okay, so that way meaningfully we connect these parameters or these inventive principles in the perspective of parameters. So that way we are going to write some meaningful statements. So if you don't understand the system while writing these statements, it's very difficult. That's the reason why you must remember always your device. Shape means whose shape? This one, this orange colored thing, shape. So pattern variations on the surface or the density variations in the bulk, you are only doing in this particular material, in this particular material. Okay, so that is the reason why uh, you have to understand this system thoroughly. Okay, now you are writing all the statements. So once the statements I worked out completely, or we are doing a different research now. So maybe you, whether you believe or not, each statement will give you one chunk of work. Trust me, each statement will give you one chunk of work. That's why I said my collaborator yesterday, I'm giving you the work sufficient to next 1 year, because each statement will give you one chunk of work they can do as far as materials is concerned. Okay, so that is the value of these statements. But writing the statement in the perspective of the contradiction is a real skill, because in order to write that, you must have understood your system or you must have understood your problem very thoroughly. Then statement will come beautifully. Okay, so that's the thing you need to get. That skill is needed, because tomorrow somebody in the research and sorry, the research and development wing, if you go, or in the design department, if you join, they will suddenly come up with some truck. That truck, they will say that please design something for this new innovative things, you please add or remove something. So that time, this kind of analysis will give completely a picture what actually can you make in this system. Okay, for that you need to understand the problem or the system thoroughly. So these are the final statements we got from our analysis. So these are the final statements we got. So changing the density of layers distribution in plane prior to the immediately connecting layer. So here intermediate layer with density distribution change. One kind of material combination we are giving. Next is pattern with pre-induced deforming agents. This is new thing we found. Are there any deforming agents in the nature, or are there any deforming agents that we can internal? That means if I shine the light If I apply the magnetic field, that will change the pattern, or that will deform the pattern, that will deform the structure. So deforming agents is a new concept we got in this particular design of this research. Okay. So now make the material distribution heterogeneous. That is, it is not homogeneous. Use different kind of materials in the same layer. I'm only talking about the middle layer. Okay. So composite material system in specific pattern with pre-induced form deformers. That is also fine. Composite material you use. Now, vertically segmented heterogeneous layers. Now, vertical you can think of impact assisted by composite bottom layer. Now, what I'm doing? New idea emerged. If I apply the forces in my device, new idea emerged in such a way that I'm applying the force in this direction. If I have some elastic layer at the bottom here, when I apply the force, it will take the force, transfer to this layer will give it back elastically. So that will actually create the double impact. You understood? So that will create the double impact. So that is a new idea we got from this heterogeneous layer with the two-side impact assisted by composite bottom layer. That's a new idea we got. Next is curved structures. Why are you using all the time the planar thing, symmetrical things? Why don't you go for curved structures? How we can create curved structures in materials they will do, that is their problem. Okay. Even creating curved surfaces like your lotus leaf, you have seen in the nature already. So curved surfaces. Okay. So that is also the idea emerged out of this practice. Okay. Next here, instead of force application, you just apply the impulse. Hope you know the difference. Impulse is force into time. And you keep oscillatable material shock absorbing composite material inside. It's secondary triboelectric device. Same thing. You just apply the impulse, then let that transmit to different devices inside. So multiple devices in single device. Okay. So that is what the idea emerged out. So layer deformation, same thing. Thickness modulation, same thing. So like that, we generated more ideas and multiple ideas where this each statement will form the basis for one complete work. Maybe you have to see almost 10 research papers are here. Believe me, 10 research papers are here. So this is what we can achieve. Now our turn. Okay, what is the time? Still okay, 13 minutes. Now our turn. I have taken only one statement for our purpose. Any questions up to now? I'll come back to the session. Yeah. Any questions up to now? Because you must have understood how complex it is to apply TRIZ method. But it has that significance, no doubt. Because it is always like the versatility of the method is you can apply to anything. Only thing is you must understand in the extremely generalized fashion. Even quantum computer you can apply. Okay. And especially in industry, academic I'm just not considering. Especially in industry, different companies, strong companies, where they have a very strong R&D, where they have a very strong design department, design wings. There, people, even though knowingly or unknowingly, they tell out or not, they're using these methods. So I thought you people should learn this. Okay. Now, before entering our bio thing, bio inspired TRIZ, you tell me, are there any questions? So let me repeat. First, you are starting with a system. You are identifying different parameters. Then those parameters are being generalized and mapped with generalized parameters of the TRIZ method. Then you are going to choose what is the improving parameter in your system. Then with respect to that improving parameter, you are working out considering all others or the worsening parameters. For each contradiction, you are going to get 3 or 4 keywords, which we call them as inventive principles. How many inventive principles are there? 40. So 40 inventive principles are there. Among them, 3 or 4 for each contradiction you choose. Those keywords are the those are the keywords to solve the contradiction, which shows the solution. Then, with these 4 keywords, we are going to form a statement meaningfully in the perspective of the contradiction or the parameter, worsening parameter especially. Okay, so that is going to make a difference. So that will give you one statement. That statement will give you an idea what to do. Okay, so that statement once you prepare, now we are going to enter to our bio inspiration. So if you have any questions, kindly let me know. Okay, so if you want again and again see the video, then you please try to understand. Now you can ask question if you have anything. Now if you see, I have chosen only one statement, that is pattern with one statement among these statements. Believe me, each statement will give one or two papers, research papers, because especially research people know, PhD people. Okay, each statement will give me one paper or two papers. So that means with a simple TRIZ analysis, I can give 14 papers or 15 papers. Okay, so that is the impact and the ability of the TRIZ method. So in this, I have chosen only one statement. Okay, one statement I'm choosing for our purpose of practicing biotriz. Now, that statement is pattern with pre-induced form deforming agents. Pattern should be there, but in that some deforming agent should be there. That make material distribution heterogeneous. When that make material distribution heterogeneous, when we apply the force. That means it must have a structure, but a structure is not the structure is not uniform with respect to time or with respect to force. Try to understand. We have a pattern, we have a structure, but that structure keep changing with respect to time or with respect to force. Do you find anything this kind of systems in nature? Now is the question. Hope my question is clear. I gave a statement. Now I am asking you, pattern with pre-induced form deforming agents, okay, that make material distribution heterogeneous. Heterogeneous means it has multiple variants or multiple variations. That may be with respect to time, that may be with respect to force. This kind of structures or this kind of deforming structures with respect to time or with respect to force, do you find in nature? So please switch on your computers or mobile phones and search. And how to search also, I already told you. What is the function is pattern deformation with respect to time or with respect to force. Are there something in nature? Anything coming to mind immediately? The forms or structures in nature that change with respect to force application or with respect to time. Maybe morning to evening, night to day, day to night, anything with respect to time. Is there anything coming to mind? Think. Maybe
So
take
with
2 minutes.
respect to touch me not plant,
Yes, one example, routine example, but that is my example. I already told you.
Sir,
Okay.
sponge.
Yes. What is that?
Sponge, sir. Like when you press it, it will compress, no, sir.
No, no, natural systems I'm asking. Is a sponge a natural system?
No, sir.
Then bio inspiration you search with this uh, statement. What you need? Pattern with pre-induced form deforming agents that makes material distribution heterogeneous. That means you have to find the pattern in the nature which changes with respect to time and or with respect to force. Think 2 minutes, I will get back. Hello, sir. Yeah, 10 minutes. Class will be over. Yeah. Sure, sure, sir. So think about it. Because I gave complete picture now. So what is the spirit of this line? Pattern is deforming with respect to force or time. Or I can give even better than that. Even with any other stimulus, that may be light, magnetic field, or anything.
With respect to time, the shape of the flowers changes.
How? So one flower you take and explain it. You can first note down which flower that is and what are the different changes and how they are taking place. Okay. One flower you choose with respect to time. So that is one example, definitely a good example, because flower structure, or that may be micro level pattern or structure, changes with respect to time. That means internally some changes are already coming. So what are those changes? If you understand, that is bio inspiration. So that is one example, definitely. Maybe I will type here. What are the other examples? Please go ahead. Flower pattern or structure change? Both are same only. With respect to time means as a function of time. That's what I mean. Second, is there any other example? Is there any other example? Second.
Sir,
Again, I'm
can you say sunflower?
no. See, flower means with respect to time, it is changing. Okay. Sunflower, how you think that match to this one? So its pattern should be changing with respect to time or with respect to application of force. I gave some liberty. You can take any stimulus. That means you may be considering light. Am I right?
Yes, sir.
So with respect to light, what is changing?
The plant structure is changing. Its orientation is changing.
The plant structure is changing, not the flower.
Yes.
Okay. So you need to consider sunflower plant. Plant structure. as a function of
time, sir, we can say, right?
not time. It's a sun orient.
So,
Yeah.
so electromagnetic radiation, we can
Yeah.
say.
Sun orientation. That's why please don't get mistaken with the sunflower. It's not sunflower. Actually, it's a plant structure. Strictly speaking, the lower portion of the flower. That is what actually turning. That means inside what is happening, you must understand. That is going to be your inspiration, not your flower. Next. Any other example? Don't see only trees or plants, animals also you can see, human being also you can see the astronomical objects, you can see any other things.
It's a
There,
tortoise.
yes. How?
So like when it feels that danger is coming, so it will mold itself into the shell, and
Hmm.
when it feels there is no danger, it will come out.
That is macro level, right? How pattern is changed.
So like its shape is changing also.
No, that is overall shape. Is there any pattern change in that skin, or what kind of change taking place in the skin or in its body? Pattern. Don't forget this.
Uh, Sir, there is an insect, no,
Pattern
sir.
with
Once we
pre-induced form deforming agents, because that should be on surface. Don't forget the pattern. Here also sunflower, I'm only talking about the below part of the sunflower where internal changes you need to look at with respect to sun orientation. That means that is the internal pattern change. In tortoise, what is going to be changed? Don't forget that. Yes, somebody else talking.
Sir, there is an insect, no, sir. When we touch it, it will swirl itself in the body. So I don't know the name
You
of the
please
insects, but
search. You please search. In front of you, computer is
yes.
there. You are free to do that. Search and tell me what is the name of that, and tell me what is and what changes are taking place.
Can we consider the color pattern also? Like a chameleon changes its color.
Yes, because color changing means yes, exactly. Color changing means something happening internal,
Yes,
right?
yes.
Pattern
Yeah.
changes. Hmm?
Chameleon changes
That you
its
look.
color.
Yeah. How?
Depends where it's staying. Like if it's staying over the trees, so the tree color it will appears over there outside, so that the predators cannot see it.
No. You are always talking what is happening externally.
Mm.
How that color change is taking place is a actual thing related to pattern with the pre-induced deforming agents.
Oh.
What you said is exact example. Exact example. You just see how color changes are happening in chameleon.
Sir, that insect is called millipede.
Is the spelling chameleon? Is this correct or ON? You also can search
Yeah, ON, sir.
ON. So chameleon color surface color modulation. Face color modulation with respect to their stimulus is not force. It is a mental force, we have to tell.
Environment
Yeah, situation. Respect to situation. Can I tell like that? That we can probe later, no issue. But whatever the pattern with the pre-induced form deforming agents, make material distribution heterogeneous so that the color is changed. Am I right? Okay, million, not here. Yeah. Next.
So that insect name is millipede, sir. So we go and
Ah.
provoke it with a stick. It will rotate itself and it will swirl itself across the body.
Then what is happening there? What is the name?
Sir, millipede, sir. MILLIPED.
MILLIPED. Okay, millipede. Okay, fine. Millipede, what is happening?
Sir, when we provoke them with a stick or something, they'll coil around themselves and they'll become dormant.
Okay. So surface pattern, how it is changing?
So the
Is it
body
becoming
structure,
flexible?
yes, sir. It will be straight like a worm. Then again, it will just swirl itself around the
Correct.
body.
So it's related to flexibility, right?
Yes, sir.
Millipede,
Flexibility.
flexibility. So anyway, flexibility related to the structure or the pattern. Okay.
Yes, sir.
So with respect to anyway, this is with respect to force only. With respect to external force. Right. So these are the examples in the nature. Now you got the bio inspirations. Kindly, my request, tomorrow class, you please sit carefully, peacefully, and work out taking one example. Please take a photograph of this. Please take a photograph of any these four. Any one you choose, and then work out what you are understanding in that particular thing as per this statement. So very deeper information you need to understand. Sunflower means you should not say sunflower is moving when the sun is moving. Why and how? Chameleon surface color is modulating with respect to situation. Then why and how? Millipede, again flexibility varying with respect to force. Then again why and how? So you have to always look at pattern with the pre-induced form deforming. So how this is happening in this? How this is happening in this? How this is happening in this? That is what you need to see tomorrow. Okay. So please take a photograph of this. Then once you understand, one example is enough. You need not do 4. If you want to do 4, you can do, no issue. But all the specific information related to pattern change or deforming agents and heterogeneous structures should be clear in these examples. If you want to do 4, you do 4, no issue. Or otherwise, you choose only one example among these 4. Okay. So then I will explain in the next week, hopefully on Wednesday, the TRIZ. Okay. That will be over in one class. So that is about today's class. Okay. So attendance over, ma, Emma. Hello.
Sir, it is over.
Yeah. Okay. So there are any questions you can ask? Otherwise, we can take off.